Okay, all right. So, sorry, I forgot the recording. We're 4 minutes in. I'm going to do a very quick. So, package so far. You can go to this account. I will show you over here. And then just download the zip file and you'll get the entire R package up to this point, up to the end of chapter 2. Or if you're a GitHub user, you'll know how to fork this or clone it to your own directory. So we're going to start. Yeah. No, that don't need that saved. And I'm going to put the. Okay, sorry. Transcript was on top of my stuff. All right, so I'm back in my office with my big computer and my second screen and no windows today. They have removed my windows. And if I am unlucky, they will also stand outside and start banging pipes in a few minutes, but hopefully keep it quiet. All right, so what are we doing today? We are going to make custom functions. So this is, I'm gonna pop the book chapter in the chat. Oh, Xenia, you did remind me to record and I didn't even see it. Thank you for the reminder. All right, so this is where we are. All the code that I'm gonna be showing you today, you can find it in here, copy and paste it. So have that up somewhere if you're gonna follow along. Okay, but the first thing that we're going to do doesn't require that you be even in the package project. We're just going to go over the basics of creating a custom function. All right, so all we need to do is new file, our script. We're not even going to save it at the moment. So functions are created with the function, which is useful. We are going to first make a quick little function that helps us do rounding with trailing zeros. So you know how when you round a number and it's like 1.497, which rounds to 1.5. And if you wanted 2 decimal places, well, actually, let's just do it here. So we do round. I could spell 1.497 to 2 decimal places. We get 1.5, but we wanted 2. Well, we want it to be 1.50. And this is going to become important for the function we're going to do later, which is how do you create APA formatted reference or results text from an analysis object. So what we want to do is create a function that does rounding, but keeps the trailing zeros. And the only way to do that is to turn our number into a string, into characters, and give it some trailing zeros. But this is a good example of a custom function. So first we got to figure out what's it called. What is we going to call this function? Try to pick a name that doesn't duplicate a function that you use a lot. So don't call it round, because it's not the same as round. You're going to be annoyed if this function runs in other places where you would want round to work. So let's call it round 0. And then we'll call the function. And how this function works, though, is you need to put a pair of curly brackets after it. And we're going to put all the code for the function in there. So almost always you skip a line. You want put your code in here in between these 2 curly brackets. And this is when we run the round 0 function, this is the code that will run. And in fact, that's the minimum you need to have a function. If you run this, so run that code here, you can look in your environment and round 0 is now a function you can use. So if we do round 0, we can't give it any arguments. What we're going to get is null, because there's no code. It's not doing anything. It's just going to return nothing, null. We can't round a number yet, 1.497, because we haven't told it that we want it to have arguments. So let's give it some arguments. Our round 0 function is going to be really like the round function. So it would make sense to give it, what were we in here? Oh, round. What is going on? There is no package called. I do not want a package called demo package spelled incorrectly to load. What is going on here? Okay, we're going to ignore that for a moment. I'm pretty sure that's not happening on your computer. All right, so we look at the normal round function, and it's got two arguments, x and digits. So this will make sense to our users. Like, it's very much like the round argument, but it does an extra thing. Let's give the arguments the same names. So we want x. We never know what x is going to be. There's no way to set a default value for the number that you want to round. So we're not going to give it a default number. The user is always going to have to say what they want to round. But how many digits we want it to round to, we can give a default number. It makes sense to give the same default number that the round function does. Then users who know the round function will, the best guess is that the round zero function does the same thing. So we can say digits equals 0. All right, so it's going to take an argument x and optionally an argument digits. If you don't say how many digits, it's going to round to 0 digits. So we can define that again. Now we can see in our global environment, round 0 function, it's got some arguments. So if we run this, we still get null because there's not actually any code in here telling us what do we do with x, what do we do with digits. We got to write that code. All right, so how do we write that code? We're going to need to actually use the sprintf function here. So if you do sprintf, I'll show you what it takes a format string. So you can tell it to format a number with 2 places after the decimal point with the format string %point to f. F is for floating point number. It's like a double. So if we did sprintf on 1.497, if we ran that, just that, then it gives us the string 1.50. But this number here, we want it to be whatever the value of digits is. So we're going to have to use a little bit more code to create the format string. So FMT is going to be our format string. We're going to use the paste 0 function, which just pastes together stuff with no separator, to paste %dot, and then whatever the value of digits is, and the letter F. And then for sprintf here, we'll just use that format string. Oh. Tooltips are very useful, except when you're teaching sometimes, when they cover everything up. And we're going to call that x0. So, oops, did not need this here. And so if we run that, well, let's set digits to 0 right now. We're just running this interactively so we can test our code. Format, so it's %.0. And if we run this, is it grumpy? Is it not? Oh, unrecognized format. I forgot the F here. There we go. So format x0, and x0 is just 1. That worked. What if we make digits equals 2? And that x0 is now 1.50. Okay, that's working. Now this number needs to come, not always be 1.497, right? What do we want it to be? It's going to be an argument that we pass to our function. Will be the argument x. So we'll set that to x0, and then the very last thing we're doing in this function is return x0. All right. So if we redefine this now, we run the round 0 function with digits equals 2 with 1.5, digits equals 4. 1.4970. So it will give you the trailing zeros. It does the rounding for you. We've got a function. All right, so a little bit about the functions. You write any code you want, and you use the arguments, the values of the arguments that are passed to the function. The arguments can have no default, therefore they're required. The user has to specify them, or they can have a default, and therefore the user doesn't have to specify them. you can just use the default value. If you have, let's say if I say up here, digits equals 3, and then I run this, what are we going to get? What do we expect to happen? Like, even if the value of digits up here is 3, if we run something like that, digits 4, we still get 4. We don't specify a value, we still get 0 digits. And that's because the arguments take precedence over any objects that are defined outside the function. So inside the function, everything in the function only knows what's going on inside the function and what are the arguments that have been passed to it. It shouldn't have to rely on, and often can't rely on, values that are created outside the function. Another thing, if you've created functions before, you might, and is fine to do, you might skip this bit. So you would just not return that. And in a function, the last thing that you make, if it prints out, say if you just ran this, it would normally just print out the answer here to the console. That gets implicitly returned. So if we defined round 0 like that, it still works. And here it's 2. All right, I like to use an explicit return value. So put that back. So that the very last line says return, and it tells you what it's going to return. It makes it really easy when you're going through your code then to figure out what's being returned. And also sometimes in some functions, you might return one value if, say, the p-value is less than 0.001. You might return one thing, and if your p-value is greater than that, you would return another format. And so you would actually have 2 return statements. Once you hit a return statement, the function sends that value back to where you've called it. So here, or it can be, like we can set it rounded val. So sends it back to be assigned to an object or used in something, and the rest of the code stops. So if I wrote some more code over here, like print hi, this isn't going to run. Run this, there we go. It's not printing hi. Or if I just ran this, we just get the 1, we don't get hi, because as soon as the function returns something, nothing else happens, the function stops running. So if you've got some things like cleanup code, let's say you created some temporary objects during your function, you save them in the temporary folder, and you want to delete them before the function finishes running. You got to delete them before you return. So I like to use the return function because then it's really explicit. Now we have stopped running the function and here's what you're going to get. Whereas if you just rely on implicit returning, that can be confusing. All right, so we've got our, let's clean this up a little bit. We don't need any of this, any of that. We've just got our simple round function. All right, the other thing that you can do here in the console, type round 0, no parentheses after it, and you will see your function here. Let me double check. I think, let's see, create formatting string. So I'm gonna redefine that. It's got a comment in it. And now if we do round 0, okay, no, it does give you your comments back as well. So it just gives you all the text of the function. You can try this for any R function if you want to know how stuff works. Some stuff like mean is frustratingly, it just tells you it uses the method mean. And this is a sort of further advanced package development that we're not going to go into in this class of methods and how you can create a function that does one thing if you give it a data frame, and it's a different thing if you give it a vector. But other functions like standard deviation will give you their code. So you can have a bit of a look at what is the actual code for calculating standard deviation with the SD function. You can look at anybody's code. Any code that you can run in R, you can look at the function. Can I go over the purpose of the format line of code? Yep. All right, so the sprintf function we're using to create that the string that includes trailing zeros. So let's look at sprintf. All right, so sprintf, the first argument to it is FMT. It's a character vector of format strings. It's how you end up formatting this number. And there's a whole bunch of different ways you could do the formatting. Do they give you? Right, so you could format it as an exponential, an integer value, a double precision value. You can, I could even, let me see. Like if we wanted this to have a literal percent after it, or my number is, I think that works too. Yeah, so it's sort of like glue, which we're going to look at later, or paste. It's a way to format, insert strings into other strings with a very specific format. But because we need this formatting string to depend on the value of digits, I need to create it by pasting together percent, full stop, whatever the digits number is, and the character F. So we get a formatting string that works to do the thing that we want it to do. Does that make sense?
Yes, thank you.
Cool. All right, so now for demo package, we're going to keep this function, but we're also going to create a function that produces the APA formatted results text for a paired samples t-test. And we'll be using data from that we inserted into the package last week, the self-res-at data set. If you don't have that one, there is some code under 3.2.1 that shows you how to just use read CSV to read it in from the internet. And then you can create that data frame to use in your development today. And then you can go back to chapter 2 and figure out how to put it into the package at a later point. Right, but if you've downloaded the whole package, it should be in the package already. One thing we're going to do just for sort of clarity, while we're doing package development, you might have installed demo package last week. So if you're working from there, let's go to the packages tab. If you've got demo package in this list, so you'll have this whole list of your library. If you type demo, if demo package is installed, uninstall it. Just get rid of it. What is going on with this? Yes, okay. Nope, that is fine. That was fine. Okay. So we don't have an installed version. We're going to be working entirely from the version that's loaded during development. So there's two ways to be able to use the functions in the package that you're developing while you're developing it. One way is to install it under here. Don't click this, but the install button installs it into your computer, just like if you do install packages for something from CRAN. It's available after you restart R. It's available in other scripts. It'll always be available on your computer. But you often don't want that. Like I've got Faux installed on my computer. I use it in a lot of scripts, but I also develop with it. And I don't want the version I'm working on that's got more bugs and different issues. And I've deleted some of the functions. I don't want that one to be the one that I use in my day-to-day work. So I only ever want it loaded in the development environment when I'm doing development. Then what you should be using is the load all function. So it's under more here. I'm just gonna copy this in case it goes away. So if you do load all, or you can just type DevTools : load _ and then a full stop inside of quotes, you'll get this loading demo package. Now you are able to use functions in your demo package like, well, the only thing we have is self-res-at. So this is the data set we'll be working with. All right, So what we're doing now, we're doing a specific instance of adding one function to a package. So the first thing that we're going to do, well, actually, all right, is work out a specific instance of like using the function that you want to develop. So you have to develop the code that you're going to use. So let's go through that quickly. So we need that self-res at data set. You need to get that loaded somehow. If it's already in your package, you can just use it. If not, you can use the load CSV text that's in the chapter like that. All right, so what we're wanting to do is do a paired samples t-test on it. So let's make something called t-results. And it's a t-test where x is self-res at, these will be the female self-resembling faces, and y will be self-res at $, the male self, no, not male, the female non-self-resembling faces. And we want to say it paired equals true. All right, so we're going to work out how do we do a specific t-test with named x and y values here. So we've got our t-results. If you print them out, they look like this. But what we want to do is turn them into the results text for like an APA formatted, in APA format. So we look in here at our t-results. It's just click on it in your environment. It'll show you, it's just a list of stuff that's got names. So we've got our statistic, 3.599, blah, blah, blah. Parameter, that's the degrees of freedom, our p-value. Confidence interval, lower and upper one. The estimate, so the mean difference between our two groups. Standard error, what kind of test is it? Is it paired or independent? And data name. And then the null value that we're testing against for the t-test. So we've got all of this information in a list, and we can pull those values out, like t_results. If we want the degrees of freedom, we $, parameter. And there we can print out the degrees of freedom. So we can insert all of those into a sort of template result section structure. So copy this from the book chapter. We'll set up our template as this. So a paired samples t-test was conducted to compare, and then you put inside curly brackets variables for anything that might change depending on what you're going to input into the function here. So it was conducted to compare DV between level 1, the mean for level 1, the SD for level 1, and level 2. The mean for level 2 and the SD for level 2. There was it's going to be either non-significant or significant. So we either do or don't put non-dash here. Difference. T with these degrees of freedom equals whatever the t value is. P equals whatever the p value is. So this is how you set up a template string for glue. I really like glue. I find it a pretty straightforward way to put lots of numbers from an analysis into results text. All right, so we need to create all of these different variables. So that's a fair number of them. Our DV here is, well, we can just do this in the glue function. So use glue template, and then say DV, what do we want that to be? It's preferences for female faces. You can copy this bit from the book. I'll chat it through and type it here. What do we want? Level 1. That's going to be replaced by this text. Participants who resembled these faces. Level 2 is going to be non-self participants? Ants. I have never spelled participants right in the first try. There we go. All right, then we've got mean one. We don't need to define these in the order that they are in the text. So I've gone a little bit out of order here. How do we calculate the mean of level 1? So we've got self-res at here, F self. We can just do mean of that. Yep, that's fine. Mean 2 is the mean for F non. SD1, just copy these. Standard deviation for that. SD2, standard deviation for that one. All right, so this is tedious. We'll get there eventually. What are the other things we need? We need a, let's do degrees of freedom first. Degrees of freedom is going to come from this T results. So remember, that was the parameter. Our T value also comes from T results. And that is the statistic. And our P value comes from T results. And it's the P dot value. And then we also needed one more thing, which is this non. So if the P value is lower than your alpha, we'll keep it at 0.05. This should say nothing. And if it's greater than or equal to 0.05, it should say non-dash. So non equals if P results $ P value is less than 0.05. Then we do nothing else non-dash. Okay, and then end parentheses for glue. So a little bit tricky here with like the number of parentheses that we have, making sure that they all work, but you can just copy this bit from the book. So if we run that, oh, template not found because I need to define template. All right. All right, what's going on here? This is terrible. We need to round. And in fact, we could use our round 0 function to make sure it's rounding in the way that we really like. So hop through all of these and round. Oh, that is already in the code that you probably copied from the book. So go through and round everything. We don't need to round degrees of freedom. For paired samples t-test, they're always an integer. T value, P value. And then we figure out how many digits do we round them all. The mean should be rounded what? 2 digits? 2 digits. Let's try to be consistent with, nope, I've done 1 for everything. Okay. And 1 for the SDs. And T value should be 2, and the P value, we're going to round to 3. Okay. Now let's run that and see, does that work? My number is, that's because I forgot to redo the round 0 function after I fixed all that. There we go. Okay. So, all right, we've got an example, like a single example of the code that we want to turn into a function. And now we got to start thinking about what is it that you might want to vary every time you run this function. Like you don't always want it to say preferences for female faces. You don't always want to be comparing the F self column from self-res at to the F non column from self-res at. You're going to want to be able to vary those each time you run the function. So we set up the function now, wrapped around this code, and then start swapping out variables for things that we're that are hard coded, what we call in the function right now. Okay, so we've got this, it's all just in a script here. And we're going to create this function. where does it go in our package? We're going to use this. Use underscore R is a function that helps you create the R script for any function. It puts it in the right place. And we're going to call this function APA underscore T underscore pair. All right, so it's going to be paired samples t-test APA style. You run that, it'll create a file called APA underscore T underscore pair .r. It will be located inside the R directory in your project. There we are. So this was our documentation for the self-res at dataset. And here's going to be our documentation and code for the APA T-pair function. So let's take everything that we did here. In fact, absolutely everything. So we're going to have to keep this round zero function defined in here. And we're going to define another function in the same file. So we'll call it APA T pair equals function, open parentheses, and we're going to close parentheses at the end. And I'm going to shrink this down a little bit so you can see it all on one screen. I'm going to take everything and tuck it in one. So that double click on the first curly brackets, find the last curly brackets, everything inside of there, that's the function code. So we run that, we'll have defined a function APA T pair. And oh yeah, let's do our explicit returning here. So we're going to assign this bit to APA text. And then at the very end, before the last curly brackets, we're going to return APA text. All right, so define that. And then if in the console you run APA T pair with no arguments, because we haven't given any arguments yet, it will do this. Now, totally ignore this P equals 0.000. That is going to be part of your, not homework, but it's one of the further learning exercises to sort out how do you make that say P less than 0.001 if the p-value is actually less than 0.001 to avoid this P equals 0 thing that isn't APA style. All right. Thank you, people who are helping each other in the chat while I ignore you all in the chat. Do turn on your microphone and yell at me if I ignore something in the chat that you really need me to go over, because it's on another screen. Okay, so here we are. Hopefully, you've got this APA T pair that takes no arguments. What kind of arguments do we want to start out with? Also, if you tried to do that and it didn't run the function, you got a message like, I'm going to do that, like could not find function APA T pair. Either you've typoed it or you haven't defined it yet. So you have to run this code, like start here, run that whole bit of code in order to define the function. And then it's going to go into your environment right now. And we'll get this loaded into your package a little bit later. Okay. So what are the arguments that we want to add? First, let's the values of X and Y. Those aren't always going to be the same, are they? So let's call them X and Y. This will make sense. They'll be the same names as the name of the arguments in the t-test function. So that'll make sense to our users. And now we need to, anywhere where we use self-res at f self in our code, that's going to be whatever the value of X is. And this will be whatever the value of Y up here is. So let's get rid of it here. X, that's X. And this one is Y and Y. Okay. So now we are no longer telling it what are the two values that you're going to compare. The user has to do that. So let's run this. And then if we try to run APA T-pair now, we'll get argument X is missing with no default. After you have one error, it just stops telling you about errors. So Y is also missing, but we won't find that out until we sort out X. And then if we try to run it, it'll give us a warning about Y. So let's put those in. The self res at $F self and Y equals F non. All right. And now we can use this to look at, let's look at the male faces, self versus non-self. Okay. So we can see here the, our t-values, degrees of freedom are the same participants, but the t-values themselves have changed. The standard deviations have changed. The means have changed a little bit. And we can do this for any pair, like M self versus F self. And here we have no significant difference between those two. All right, now there's some other things. What else are, so it didn't make sense, the labels, when we were looking at M self versus M non, right? Because that's for male faces and participants who resembled and didn't resemble. But we can put anything in there. So we probably want people to be able to specify what the DV is and what's level 1 label and what's the level 2 label. So what we can do is go back up into the function text, the function definition, and add 3 more arguments. So DV, and let's give this one a default. Let's see, just make this match the chapter. So the default label is just the DV. So it can be a very generic thing. And then we can skip lines here to make this a little bit easier to read. Level 1 label is going to be just level 1. And then the level 2 label will be level 2. All right, so we've given defaults. They're generic defaults that will work for anything, but you could make them more specific. So now we don't need to say DV equals, you could say DV equals DV, but Glue is actually smart enough that it will use the DV level 1 and level 2 values from the function for that. All right, and then everything else is being calculated from the arguments that we've created. So let's redefine this function. We just run that. Now we get a paired sample t-test was conducted to compare the DV between level 1, etc. So let's see what happens if we use non-default values. So preferences for male faces. Let's watch me spell terribly again. Level 1 is participants who resemble those faces. And I've done it again, haven't I? Level 2 equals non-self participants. Oh, I did it right this time. Okay, so if we run that and double check that, yes, it's replaced the DV level 1, level 2 in the right place. And we've got our string. Okay. So now that we've got two functions defined here, you can define more than one function in the same R script is fine. Typically, if it's an important function that users are going to be able to use, that's the name of the script. And then if there's any kind of helper functions like round 0, users aren't going to be able to use that. We're just using it in our script. I'll put it in the same script. It won't get its own file. You can choose for yourself. Some people believe in like defining all of their functions in one script. I find that confusing. Some people make a new script for every single function, even the little tiny ones. All right, so here we've got a main function and its helper function. They don't need to be defined in this order. I can put round 0 actually at the end. I'm going to get rid of this example that I've been just working on for testing. You can define them in this order, and that's fine. Let's save this APA tpair, and we're gonna restart R. So get rid of everything in your environment so that you're definitely not relying on the stuff that's in your environment. So we're going to now add these to our package. So there's a few steps for this. One is to import any dependencies, that is other packages that you're using in your functions. You need to tell your package it's going to depend on that. Your package won't work unless we have glue. So you might be thinking, why didn't we do library glue? And then we could just do glue, right? When you're doing package development, that doesn't work. You can't ever use the library function in package development. You always, if you're using functions that are in another package, you always have to say the package name, 2 colons, the function name is just a rule. So we know that we're using the glue package. It's now a dependency of our package. So there's a use this function that helps to, it adds a line to your description and your namespace files that let your package know it has this dependency. So it's use package and glue. So you'll get this sort of text. You'll say adding glue to imports field in descriptions, and then it will remind you, you have to refer to glue functions with glue : function name, right? So what that did is in your description file, that adds a section of imports, and it just makes sure if you use this function, it makes sure everything's parsed right. If you add more imports, they need to have a specific spacing and commas and stuff. And if you mess it up, then the whole package won't install. So if you just insert it using use this, those sort of typos don't get made. But you can manually edit this as well. Okay, so we've set up our dependency. Save this. I'm going to get rid of this old file. So what you should have now is inside of your R folder, that's self-res at R. Nope, not that. The APA tpair that defines those 2 functions. Now we're going to load our package. So it will reload our package and any new functions that have been created. Go under your build tab, load all, or you can type it in. All right, so it's loaded your demo package. Now you should be able to use APA tpair self-res at fself, self-res at F9. You see that these things, they're not in our environment. We restarted the environment, but because we've loaded our package, all of the data sets and functions are available to us to use in scripts or in the console in our development environment. So I can look at that, and this has worked. We can also, we can't look at the documentation help because we have not written any. All right, so let's see. Dun, dun, dun. Error, unused arguments. Miriam, if you have got unused arguments, then you need to redefine APA tpair. So like copy paste the whole thing. And well, while you're developing, then you just run the whole thing here and make sure that your function that's in the environment has an X and a Y argument to it. If you look in the environment and your function doesn't have X and Y arguments, it's still using like the old definition. You might have defined it before, you've edited the code, but you haven't redefined it. It's just the same as if you do like x equals 1, and then I run that code, and in my environment, now x equals 1. But if I do this, x equals 2, x doesn't magically equal 2 until I rerun this code. Same thing with a function. APA tpair won't equal your updated stuff until you rerun the code to define that function. Did that help? All right.
Thank you.
Okay, load all, we've got modifying error in load all. Selfres at.r caused by error in ncal. Selfres at.r. So, Joss, what is your selfres at.r? Does it look like this, or does it have any code in it, including something that has ncal? Because it should have no code in it whatsoever. We did create in the data raw folder. There's also a file called selfres at.r where we prepped that data file to be added to our data set, to our package. So it got added to our package like this. This is just the code that like prepares the data set for adding to the package. The data set that is added to the package is inside data, and it's a .rda file. Any data set that's in a package needs to be an RDA object. And then in the R folder, selfres at is just the documentation. So it just looks like this. So it sounds like you've got some code in this file that's causing the problem.
I have code in this file.
So in this file, so if we're in demo package, the R folder inside selfres at.r, it should only look like this. So have these hash and a single quote, all of that. And then the last line is selfres at inside of double quotes and no other code.
Got it.
If there's any code in that file, that will give you the kind of error message that you found.
I see. Thank you.
All right. Right. So the I think we can just do questions now. The rest of the chapter here is going over that install versus load distinction. So like, just make sure I'm not doing anything weird here. Save this. So if I restart R, I've got totally clear environment. Now, if I try to do self res at, it's not found because I haven't loaded my package, my development package, and it's also not installed. So if I try library demo package, it'll say there is no package called demo package. If you want it installed so that you can use it in other sessions, like that's a fine thing to do once you've got a package that's doing something useful for you. Right now, let's not install it. You don't want to be accidentally using it in other places or using the installed version, even though your development version is like further ahead and has new functions. If we use load all every time, so in the build tab, load all, it's just loading the development version for us to work on while we're developing. That's the best way to work on things. So now that it is loaded, we can load selfres at, we can look at the documentation for it, and we can also use our APA, where am I here? APA tpair. I was just gonna, yeah. Ooh. Oh. Well, I'm creating a standard deviation of 0 and screwing up the t-test, aren't I? Our norm 10. There we go. Okay. Just putting random numbers in there. How does this work when my environment appears to be empty? That is because we've actually, it's in our package now. So those functions are no longer needing to be defined in the environment. They're defined in our package. Our package, if we type in the console here, demo package. Oh, what is it? Do we need dev tools document? No, okay. No, it's not showing up in the tooltips because we haven't written the documentation yet. Next week is when we're going to write the documentation, which is a really important part of creating a function, is all the documentation saying, like, for each of these arguments. So you tell people, what does the function do? What are each of the arguments? And give some examples to people for how do they use the function. And once we write that documentation, then it'll automatically create help files and also be available in the sort of drop-down menu of stuff that's there when you have the package. All right, so we've hit the end of the hour. If people want to stick around and ask specific questions, and we can work through screen share your blocks here. Are there any general questions about adding functions to a package? There's a bunch of further practice for this that will be really useful if you can go over it. So add an argument to your function called alpha that lets the user set an alpha criterion, so you're not always using 0.05 to determine significant or non-significant. Edit the function to handle p-values less than 0.01. So what extra code are you going to need to put in there in order for the output to say p less than 0.01 if it is, or p equals whatever if it's larger? You could add 95% confidence intervals. You could allow the user to set a custom confidence interval. Maybe the default's 95%, but they could also set 87%. And then to create another function to produce the text for some different analysis that you're familiar with in R, like for an ANOVA or a correlation, or anything using the data from maybe your own package. All right, Tom, what's your question about dependencies?
Hi, Lisa. That was really great. I just had a question about, obviously, when you're using dependencies like that, to what extent do you need to worry about other people changing their code and it breaking your code? What's the best way to sort of handle that? Do you need to kind of reference a specific version of a package, or is it best in some cases to actually take their code and bring it into yours? And
so, like for info, there's only one function I use from mass, which is MVR norm. And actually, I've written a slightly more efficient version of it, kind of cribbing from that, and have written clear notes in my code that this is where I got the original idea from. So rewriting other people's code, if you're only using one thing or like even only a part of their function, is often useful and is not stealing, but you should clearly credit, at least in the comments of the code, where'd you get this function from? Many people try to make their packages use as few dependencies as possible. This is something that's going to require a bit of experience in knowing about, is this particular package, like LME4, the Lemur function isn't going to go away, and they're not going to make major changes to it without like a major overhaul of how we all do mixed models anyway. So you're pretty safe using that one, and there's not really an alternative. Whereas if you're using a package from somebody else, that package is also in development, it's not on CRAN, or it's like newly on CRAN, but you're not quite sure if the developer is a reliable person, you might be more wary about using functions from their package. I don't know if you know about the great CRAN debacle of 2 or 3 weeks ago, where one of the dependencies of ggplot2 had a warning, and CRAN said they were going to get rid of it on CRAN, and therefore anything that used that as a dependency was also going to be archived, which includes ggplot2, and therefore anything that uses ggplot2 as a dependency was also going to be archived. And they sent like 1,500 of us an email saying our package was going to be archived soon, because the developer of a package I've never heard of was on vacation and didn't answer his email quick enough. That's all been fixed, but this is the kind of debacle you can get into of your package will get archived if the original person's package broke, but you can, in the description, say specifically like there's a version that it needs to use, or it needs to use a version that's greater than or equal to some minimum version. So there could be like, this is not going to run well with an old version of Glue, but as long as you've got version 2 or higher, then this should work, or 2 or lower, or this specific version. It can make it a little bit harder for people to install it if you set a specific version every time. So most people try to like minimize the number of packages they're importing and use functions that are unlikely to change. So including a function that the developer says specifically is like an alpha version, it's under development. That's why we have those little the badges for stuff that say whether something's kind of stable or under development. And if somebody says it's not stable, don't rely on it. Does that make sense?
That's great. Yeah, that's really good. Thank you.
Right. Oh, I'm gonna turn off the recording here. Stop recording.